Lesson: Auditing Autonomous and Self-Learning Systems. Auditing autonomous and self-learning systems presents unique challenges and opportunities in the field of artificial intelligence compliance and ethics. As these systems become increasingly prevalent, auditors must possess a robust understanding of their complexities and be equipped with effective tools and frameworks to ensure they operate within ethical and legal boundaries. This lesson provides actionable insights, practical tools, and step-by-step applications to enhance proficiency in auditing these sophisticated systems. Autonomous and self-learning systems, by their nature, are designed to operate with minimal human intervention, continuously adapting and improving through data-driven learning processes. This characteristic, while beneficial for performance and efficiency, introduces a new layer of complexity in auditing. The opacity of AI decision-making, often described as the black box problem, necessitates the development of specialized auditing techniques to uncover and understand the underlying algorithms and data processing methods. One practical tool that auditors can employ is the use of explainable AI frameworks. XAI aims to make AI models more transparent by providing insights into how decisions are made. For instance, the LIME framework allows auditors to interpret complex models by approximating them with simpler, more interpretable models for specific predictions. By applying LIME, auditors can gain insights into the decision-making process of self-learning systems, identifying potential biases or ethical concerns. In addition to XAI, model auditing tools such as fairness indicators can be integrated into the auditing process. These tools provide metrics to assess the fairness of AI models across different demographic groups. For example, Google's fairness indicators offer a suite of metrics that help auditors evaluate the performance of machine learning models, ensuring they do not disproportionately disadvantage any particular group. By implementing these tools, auditors can proactively identify and address biases in AI systems, aligning them with ethical standards and regulatory requirements. Another critical aspect of auditing autonomous systems is data integrity and governance. Self-learning systems heavily rely on data inputs to refine their algorithms. Therefore, ensuring the quality and integrity of the data used is paramount. Auditors should employ data governance frameworks such as the DAMA-DMOK to establish robust data management practices. By implementing comprehensive data governance strategies, auditors can ensure that data inputs are accurate, consistent, and compliant with relevant regulations, thereby enhancing the reliability of AI systems. Furthermore, auditors must be adept at evaluating the ethical implications of AI deployments. The IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems provides a comprehensive framework for assessing the ethical considerations of AI systems. This framework emphasizes principles such as accountability, transparency, and privacy, guiding auditors in evaluating whether AI systems align with societal values and ethical norms. By integrating these ethical guidelines into the auditing process, professionals can ensure that autonomous systems operate in a manner that respects human rights and promotes societal well-being. To illustrate the practical application of these tools and frameworks, consider the case of a financial institution deploying an AI-driven credit scoring system. Such systems autonomously assess the creditworthiness of individuals, often using complex algorithms that incorporate a wide range of data inputs. Auditors tasked with evaluating this system would begin by applying XAI frameworks like LIME to understand how individual credit decisions are made. By doing so, they can identify any potential biases, such as racial or gender discrimination, present in the decision-making process. Subsequently, auditors would utilize fairness metrics to ensure that the credit scoring system performs equitably across different demographic groups, addressing any disparities that may arise. Simultaneously, auditors would implement data governance frameworks to ensure the integrity of the data used in the credit scoring model. This involves verifying the accuracy and completeness of the data inputs, as well as ensuring compliance with data protection regulations such as the General Data Protection Regulation. Additionally, auditors would evaluate the ethical implications of the credit scoring system using the IEEE ethical framework. ensuring that it aligns with principles of fairness, transparency, and accountability. Statistics underscore the importance of such rigorous auditing practices. A study by the AI Now Institute found that biased AI systems can lead to significant adverse impacts on marginalized communities, with algorithms often amplifying existing social inequalities. This highlights the critical role of auditors in identifying and mitigating these risks, ensuring that AI systems contribute positively to society. Effective communication is also essential in the auditing process. Auditors must be able to convey their findings to stakeholders in a clear and actionable manner. This involves not only presenting technical details, but also translating them into insights that are relevant to business objectives and ethical considerations. By fostering open communication channels, auditors can facilitate a collaborative approach to AI governance, involving diverse stakeholders in the decision-making process. The integration of these tools and frameworks into the auditing process requires a strategic approach. Auditors should begin by conducting a comprehensive risk assessment, identifying potential areas of concern within the AI system. This assessment serves as the foundation for determining the appropriate tools and methodologies to employ. Subsequently, auditors should develop a detailed audit plan outlining the steps and resources required to effectively evaluate the system. Throughout this process, continuous monitoring and feedback loops are essential to ensure that the auditing practices remain relevant and effective in the face of evolving AI technologies. In conclusion, auditing autonomous and self-learning systems demands a multifaceted approach that combines technical expertise with ethical considerations. By leveraging practical tools such as XAI frameworks, fairness metrics, and data governance strategies, auditors can effectively evaluate the performance and ethical implications of AI systems. Through rigorous auditing practices, professionals can ensure that autonomous systems operate transparently, fairly, and in alignment with societal values. As AI technologies continue to evolve, the role of auditors in safeguarding ethical and legal compliance will become increasingly critical, underscoring the need for ongoing education and adaptation in this dynamic field.